something out of here to write with? You don't have something to write with? You can grab something out of here to write with. Alright, so an example of what that would look like would maybe be something like this. First of all, a lot of times you're going to see like a little bracket like this, and that just puts the equations together. Just do the best you can to draw those brackets. They're not always the easiest to draw. So if I had 2x plus 3y equals 6, and y equals 4x minus 1, this is an example of a system. I'm putting two equations together. Later on in some math classes, sometimes we put three equations together. Not in this class. Okay, the solution of a system. The solution of a system is the point, so I'm talking about a point on the graph, of intersection of the two equations. The point of intersection of the two equations. Okay. Now, notice I said the point of intersection of the two equations. What would happen if we intersected is that point actually would be on both lines. So, I'm going to put a little star here, because sometimes I'm going to ask you to check if something is a solution. If I ask you to check if something is a solution, it has to make both equations true. Has to make both equations true. Yeah.
What does it mean, like, by making this true?
Okay. So, for instance, let me do the solution to this one if I can. I'm finding the solution of one of these so I can show you what I mean. Okay, so in a second, we're going to find that the solution of this one down here is -1, -1, okay? So don't write this down yet, but we'll see it in a second when we graph it. If I were to put -1 in, because this is an x and a y, if I were to put -1 in for x and y, it would make it true. Okay, so watch. I'm going to put -1 in for x, so 2 times -1 plus 1. I get -1, isn't that what y was? Okay, let's check over here. If I put -1 in for x, -3 times -1 minus 4, I get -1. So it works in both equations, it makes them both true. Okay? Alright, so today though, we're going to solve by graphing mostly. So if I ask you to solve by graphing, we're going to just graph the two lines, and we're going to find where they meet. Now what you're going to find sometimes is it might not be exact, and that's okay. We're going to try our best, but sometimes they meet at a point where it's not exactly on an ordered pair, like it's a half or a third or something like that. Alright, so let's start with this one. How would I graph 2x plus 1? Y-intercept of 1? And I'm going to go up 2 over 1. Okay, let's graph that one. So there's 0, 1. Alrighty. And if I were to go backwards, it would go through that point too. Alright, let's do the other line. How do I start this line? I start at a -4. Careful. Yeah, I go down 3. Now you're going to have to go off the grid a little bit. 1, 2, 3 over 1. But let's backtrack. If I were to backtrack, couldn't I go back 1 and reverse it up 3? Ooh, look at that. Do you see how I found a point where they touch? Okay. Remember, the solution is the point of intersection. That's what I said above, right? What is the point of intersection? -1, comma, -1. That is my solution. Okay. So then, let's check, like I said before. If I'm going to plug -1 in for y, does that equal, so I put a little question mark, 2 times -1 plus 1? And it does. So I'm going to put a little check mark there. And then I'm going to check -1, -1 in the bottom one. So does the y is -1, does that equal, it should be a question mark, -3 times -1 minus 4. So -3 times -1 is 3. 3 minus 4 is -1. It does. We're just checking to make sure our solution works. Okay. And so we've talked about the different ways to graph before. I'm going to show you that in a second. Now, sometimes the two lines meet. Sometimes other things happen. Let's take a look at the next one. I'm going to first graph the bottom line because it's already in slope-intercept form. So what's the y-intercept of the bottom line? 3. And then I'm going to go down 3, right 4. So this was 0, 3, 4, 0. If I need some more points in a second, I'll add some more. Okay. Now, I'm going to, just to practice graphing different forms, the top line is in standard form, right? So I'm going to graph it by finding the x-intercept and y-intercept. To find the x-intercept, I'm going to plug 0 in for y. Can you guys tell me what happens? Good. So x equals 4, that's the point 4, 0. Ooh, interesting. Isn't that the same as the other line? Okay. Let's find now the y-intercept. So this time I'm going to plug 0 in for x and find y. I do that. 4y equals 12, y equals 3. Hey, hold on a second. What happened? If I were to draw this line, what do you notice? It's exactly the same line. Now, I couldn't tell at first because they were in different forms. Okay, so let's talk about when this happens. We call this coinciding or coincident lines. They're the same. Or another word we use in math when something is the same is we call the solution we say it's an identity. And what that means is every single little point that's on the pink line is also on the purple line. So if I said, well, what is the point of intersection? Could you list them all? No, because the whole time they're intersecting, right? So what we would say then is there are an infinite number of solutions to that. There's an infinite number of solutions. So this is a special situation when we have something called coincident lines. Exactly the same line. They touch everywhere. Lots and lots and lots and lots of solutions. All right. The last case, the last example, maybe you can tell without me even graphing it before we start, because we learned something about this before. What kind of lines are these? Parallel, somebody said. How do you know? Riley? The slopes are the same, yeah. So the slopes, when you have y equals the 3s, those 3s are the same slope. If two lines are the same steepness and their y-intercepts are different, they're not going to meet. Let's graph them a second though, okay? So this one, the first one has a y-intercept of 2 and a slope of 3. So I count up 3 over 1. So this is the line y equals 3x plus 2. And then this one, what's the y-intercept of this one? Negative 2. But I still go up 3 over 1. Cut. So we describe this as parallel lines this has no solution.